Hello again, welcome to another lesson in geometry. Today we are covering section 11-5, volumes of pyramids and cones. So we have some vocabulary here. Write L, W, or H for the label of length, width, or height of the rectangular prism at the right. Explain how the length, width, and height of the cube are related. So usually we call this the length, and that's the width, and that's the height. And they're related. The length and the height of a cube are equal. So for a cube, L is equal to W is equal to H. So a cube is a special rectangular prism where all of the faces are the same square. All right, circle the correct statement in each exercise. The width of a cylinder is the radius of the base of the cylinder. Or the height of the cylinder is the length of the altitude of the cylinder. So the height of the cylinder is the length or altitude of the cylinder. That's correct. The width of the cylinder is not the radius, though. Okay, we wouldn't say that. All right, number 4. The height of a pyramid is the length of the segment perpendicular to the base. And that is also true. Okay. The slant height of a pyramid as the length of a segment perpendicular to the base. That's not. So the slant height is not perpendicular to the base. Okay, remember the slant height is perpendicular to one of the sides of the base. It goes down the side of the pyramid, not through the middle. All right. Vocabulary builder, volume. So related word, capacity. Main idea, volume measures the quantity of space or amount, such as the loudness or sound of a collection of books. Such as the loudness of sound or a collection of books. Definition. Volume is the amount of space that a three-dimensional figure occupies measured in cubic units. So this is our important one for volume for math definition. So the volume of a bottle of juice is 2 liters. Okay. So write T for true or F for false here. A synonym for volume is capacity. That's true. How much will fit inside it. Volume is measured in square units. This is false. That's area, not volume. And you can find the volume of a circle. This would also be false. You would find the area of a circle, but you could find the volume of a cylinder or a cone, which has a circle in it. All right, so 11-8, volume of a pyramid. The volume of a pyramid is 1/3 the product of the area of the base and the height of the pyramid. Complete the formula for the volume of a pyramid. So we would just put 1/3 times the normal prism that this would be. And the reason is, if you were to have a prism that's identical and base height as this guy, ooh, that's a terrible looking prism, so let's try that again. So our prism would have the same square for the base, okay, and we want to give it the same height. And then it would take 3 of these poured in here to make it work. So you'd have to pour 3 of them in to fill it up, okay? Because that prism of the same height with the same base would be 3 times as big in volume compared to the pyramid. All right, 11-9, the volume of a cone. It's the same formula as the volume of a pyramid, 1/3 base times height, except we know that big B is a circle every single time, so sometimes we shorten this to just pi r squared times height. So our equivalent formula will be 1/3 pi r squared times the height. Not that thing. All right. So write the formula for the volume of each figure below. So this one's going to be 1/3 times big B times h. Okay. In this case, the big B is a triangle because it's a triangular pyramid. And this would be 1/3 times big B times h again, except we would replace big B with the area formula for a circle this time. Problem number 1 down here, find the volume of a pyramid. So a sports arena shaped like a pyramid has a base area of about 300,000 feet squared and a height of 321. So this is the area of the base, and this is the height. Okay, what is the approximate volume of the arena? So we know the area of the base is about 300,000, and we know the height is 321. And we need to find the volume, so we're going to substitute the given values into the formula. V equals 1/3 BH. All right, so let's put those in. So V equals 1/3 the area of the base times the height, which is 1/3 times 300,000 times 321. And when we multiply those three things together, we're going to end up with 32 million, okay, 100,000 cubic feet. Okay, so this makes it, these two together will make 100,000, and then we times that by 321 will make 32,100,000. Okay, on page 3 we have problem number 2, finding the volume of a pyramid. And what is the volume of a square pyramid with base edge 24 meters and slant height of 13 meters? So remember, to find the volume of a pyramid, we don't actually need the slant height, we need the regular height. So we have to label what we have. So it's a square pyramid, so all the sides are volume square pyramid base edges of 24. So all the sides are 24. And then our slant height here is 13. So we need to find the actual height of the pyramid. So you can see this triangle in here that has the height. It's a right triangle, okay? And we have the height of that triangle going through the middle here, so that would be 13. That's our slant height in this case. And then we have this piece which is halfway across one of the sides, so this would be 12 here, okay? Two of them together would make the 24 for one side. So to find the height of the pyramid, we're going to use our hypotenuse of 13 squared equals the height of the pyramid squared plus 12 squared, okay? And that's an apothem for the base. So 169 is equal to h squared plus 144. Then I'll subtract 144 to both sides to get 25, and then square root to get the height of my pyramid is 5. Now we need to find the area of the base. This is a square pyramid, so the base is 24 on each side. So 24 times 24 will give me 576. So our formula here is going to be 1/3, because it's pointy on top, pyramid, times the base, area of the base times the height, which will be 1/3 times 576 times our height of 5. And when you multiply all that together, you're going to get 960. So the volume of this pyramid is 960 meters cubed. All right, problem number 3, finding the volume of a cone. So a small child's teepee is 6 feet high. That's the height of the cone, with a base diameter of 7. So all the way across the circle on the bottom is 7. What is the volume of the child's teepee to the nearest cubic foot? So we've already labeled the cone, and then our radius is going to be 3.5 feet, halfway across, so only half of 7. All right, so let's start with our formula. 1/3 big B times h. And in this case, since it's a circular base, pi r squared goes in there. And then we'll substitute r and h in. So this will become 1/3 pi, and in place of r, we'll give us 6 squared. And our height would be, this would be 3.5 squared. That's our radius. And our height is 6, okay? All right, so we'll simplify this in terms of pi. So we'll square the radius and simplify, and we're going to end up with 24.5 pi. And then we can use our calculator and estimate here. So this will be about 76.96902, keeps on going. So we round this to 77 cubic feet, okay? All right, let's scroll down for problem number 4. Find the volume of an oblique cone. So it's not going to be any different just because the cone is slanted. It's still the same formula, so that's kind of nice for us. Our height is 12 in this case, and the radius is 6. So the radius is this 6 right here. And the height is the distance from the circle up to the point. And we go at perpendicular, but we have to go outside to find the perpendicular. But it's still okay for our height. That cone would still be 12 tall. So which formula are we not going to use? Well, this is a formula for all pointy things, cones and pyramids. This is the formula for cylinders and prisms, so we're not going to use that. And then this is the replace big B with the area of the base formula, so pi r squared. Okay. All right, let's flip it over and finish up this problem. Find the volume of the cone. So the volume of my cone is going to be 1/3 times big B times h, which replace big B with pi r squared. And then we're going to put in our radius, which was 6, and our height, which was 12. Okay, we can work that out to 144 pi. Okay, and we're asked to find the volume of terms of pi, so this is our final answer, 144 pi meters cubed. And then it says, okay, now find it, round it to the nearest cubic meter. So if we type that on our calculator up here, this is going to make about 452.3893, so forth. So that'll be about 452 meters cubed. All right, so as always, pause your video, try the lesson check yourself, and then come back and see how you did. Okay, welcome back. So our lesson check says, a square pyramid has a base edge of 13 feet and a height of 10 feet. A cone has a diameter of 13 feet and a height of 10 feet. Your friend claims the figures have the exact same volume because the volume formulas for a pyramid and a cone are exactly the same. V equals 1/3 area of the base times the height. What is her error? All right, so for 28, if the volume of 1/3 BH is the volume formula for both pyramid and a cone, and this is yes, it is. They have the same formula. However, this B takes the place of an area formula. So we're going to plug in different formulas for our area. All right, so underline the correct word to complete each sentence. The base of a square pyramid is a polygon. It's actually a square, right? That kind of polygon. And the base of a cone is a circle. This is why they're going to have different answers. So circle the base used in the formula for the volume of a cone. That's going to be this one. That's the formula we'd use. And underline the base used in the formula for the volume of the square pyramid. That would be side squared. So this one's neither one. That would be for a triangular prism. All right, so, or pyramid. Explain how you, now explain your friend's error. She forgot that the area formulas for the bases were different. Okay, one of them is a circle, one of them is a square, so they're not going to have the same area for the bases. Okay, even though they look like they have the same numbers. This one's for the edge of our square, so this would actually have an area of 13 by 13. And this one's for the diameter of our circle, so this one would actually have an area of pi times 6.5 squared. And these two are not equal to each other. All right. Okay, so that concludes our lesson for the day. Let's check off how our success did. So do you understand the word pyramid? I think you got that one. Cone you probably have. We've been talking about oblique for a while. And volume, this is our second day on. So you should be pretty good with the vocabulary. Now, can you find the volumes of pyramids and cones? Well, what's the only difference between pyramids and cones and prisms and cylinders? And that would be 1/3. So I'm kind of guessing you're okay on this too, but if not, as always, go back and re-watch some of your video and make sure that you understand before you come to class next time to practice.